Bismillah ar-Rahman ar-Rahim. Let's look at this last problem in chapter 2. Let's read the voice. A is 1 meter, A is 1 meter, B is 4.5. Now, he need to find the angle between, cable AB and AC. AB is from here to here, and AC is from here to here. Well, he did not give you the forces inside AB. He did not give you the forces inside AC. So we need to find out the position vector, and then later on we should find out the unit vector. Let's look for point A. Let's look at point A. Although he gave you this force, but this force is not needed. If you want to find this angle, you need to use the equation given in the notes, and that's, you should know it by heart. Theta is cosine inverse force AB dot force AC over, these are the forces as vectors in Cartesian format, and this is a dot product over the force AB in magnitude times the force AC in magnitude format. Now, we don't have the forces of the cables, so we need to find out the position vector. Let's look for point A. Point A, what is the coordinate of point A? Point A is here, and it is in the x-axis, so it is 2b. B is 4.5, so 2 times 4.5 is 9. 9 in the x-axis, positive x-axis, 9, 0, 0, and that is in meter. Okay, let's look at point B. Point B, in the x-axis, there's nothing. You can see point B, it is in the wall between Y, and of course, this is Z. It is not shown. You can see it in the problem. That is Z. So B is in the wall in the YZ plane. It's not in the X. So the X is 0. What is the Y? You can see the Y from here to here. That is A. A is 1. What is Z? Z, you can see it from here to here, and that is 2A. 2A means 2 times 1, 2. We find B. Let's find C also. Let's find C. C is here. C is also in the YZ plane, in the wall, in the YZ plane, so X is 0. Now, Y, it is this one, which is A. A is 1 meter. And Z, it is this one, B, and B is 4.5 meter. Okay, we have the coordinates. Now we could start doing the position vector AB. So you should find out the position vector AB, and that is B minus A, 0 minus 9 minus 9, I, 1 minus 0, J, 2 minus 0, 2K. This is in meter. Now you go and find out the magnitude of that position vector. 9 squared plus 1 squared plus 2 squared. And that is, let's see, 9 squared. Nine times 9, 81, plus 1 plus 4, and that is 86. So square root of 86, that's 9.27. So this is 9.27. That, of course, is in meter. Now, from this, you can find out the unit vector AB. So the unit vector AB is equal to the position vector minus 9I over 9.27 plus J over 9.27 plus 2K over 9.27, and that is without units. So we found unit AB. Let's find the position vector RAC. RAC is equal to C minus A, 0 minus 9 minus 9I, 1 minus 0 plus J, 4.5 minus 0 plus 4.5 K. That is in meter. Let's find the magnitude RAC. The magnitude RAC, it is 9 square plus 1 square plus 4.5 square. And that is equal to 4.5 bar 4.5 plus 1 plus 81, and that is 10.11. So this is 10. So we found this. You could find the unit vector AC, and that is equal minus 9I over 10.1 plus J over 10.1 plus 4.5K over 10.1, and that is without units. Since we have the unit vector, we could find the angle between these two cables. Cosine inverse. Now we don't have the forces. We could use unit vector then, because unit vector will show you the forces easy. Unit vector AC dot unit vector AB over, of course, the magnitude of unit vector AC is 1 times the unit vector of AB is 1. So there is no magnitude for unit vectors, always equal to 1. So once you dot the I times the I, so cosine inverse, what is the I? Minus 9 over 9.27I plus J over 9.27 plus 2K over 9.27. This is dot. Ooh, so I have to have some space. Okay. Okay, so this is times, this is minus 9, I mean not times, dot product over 10.1 plus J over 10.1 plus 4.5K over 10.1. And of course divide by 1, so you should multiply this times this. Theta is equal to cosine inverse minus 9 over 2.7 times minus 9 over 10.1 plus 1 over 9.27 times 1 over 10.1 plus 2 over 9.27 times 4.5 over 10.1. That's it. You find the answer, do the cosine inverse, make sure that the angle is in degrees. Now, the next question is to find out what is the force, determine the magnitude of the component of the force F, okay, acting along the cable BA and express it as a Cartesian vector. First of all, he wants to find the magnitude of that force on the cable AB. So how could he do that? So let's look at the equation we have in class for the perpendicular force. So you put the equation for the perpendicular force. F perpendicular is equal to, this is going to be in scalar, is equal to the force in vector format dot the unit vector. He wanted in what? He wanted in the cable BA. BA, we have it here. We have the unit vector BA. That is it. So we put this force, which is, we have the force as 300I minus 260J 640K. This is dot what? Dot the unit vector, because he want the perpendicular. Where is it? Determine the magnitude of the component force acting along the cable. Not perpendicular, the parallel to the cable BA. This cable, so the unit vector is BA is minus 9 9I over 9.27 plus J over 9.27 plus 2K over 9.27. So now, you multiply this times this. Of course, you ignore the I. You multiply the minus 260 plus this. Multiply the 640 times this, and then you could get the number in scalar format. Now, and put it here. Once you finish this, now he wants it in Cartesian format. That's okay. To find it in Cartesian format, you have to multiply this magnitude with the unit vector. So once you find this in scalar, if you want to find out the force in Cartesian format, look as a vector, it's equal whatever you found before times the unit vector. Of course, here this is unit vector AB times the unit vector AB. Now the force barrel would be in IJK in Cartesian format. So you could put it in IJK, and that's going to be in Newton. The last one, what is the force perpendicular to that cable BA? Same cable BA. Well, you know from the notes, the magnitude of that perpendicular, and he wants in magnitude format, is equal F squared. We have the F squared. We have to find the magnitude of this force squared. Okay, minus the force parallel square, and that is all under the square root. Now we have this, the F barrel from here in scalar format. You square it, and now this force, of course, you have the force from here, the force in magnitude format. It's 300 square plus 260 square plus 640 square under the square root. You find out the force in magnitude format, of course, in Newton. Once you have this, you square it minus the force parallel, also in magnitude format, square, all under the square root, and that is the force perpendicular. This force perpendicular to that projection of that force perpendicular to that cable AB. I think that's it, and you could finalize everything from the chapter 2, and this is it from the last problem of chapter